Welcome back to part 2 to our Pleasureway Ascent power system upgrade. In this video we'll be focused on installing a DC-DC charge controller into my 2018 Pleasureway Ascent. So on 2018 Ascent, the alternator charger was handled through direct alternator charging. So Pleasureway put a solenoid underneath the driver's seat and also leveraged a Mercedes-Benz relay in parallel with that. The Mercedes-Benz relay is associated with the aux battery upgrade in a Sprinter van. Basically, both of those devices get switched when the ignition switch is turned on. So when the engine's running, the relay and the solenoid are engaged, and that charges the house battery directly. So the house battery, lithium batteries are connected directly to the engine battery and alternator of the Sprinter van. So a very rudimentary charging system, no isolation between the two battery systems at all. So I think that alone is worth the upgrade. The main reason I'm doing it at this point is upgrading to the Lithionics battery. That charging system isn't compatible at all. It would likely damage the battery long term. So I've decided to upgrade, and I've chosen the Victron 30 amp DC-DC charge controller to install. I like the Victron for multiple reasons. Just you get a lot of good data on it as it's running, so you know it's operating correctly, and you get some statistics on its use. The other nice thing about the Victrons is you can parallel them. So I'm going to start with a 30 amp, and I'll gradually expand it to add a second one, so I'll get effectively 60 amps off the alternator through a regulated DC-DC charge controller that and it basically outputs a charge profile that I can tune to be compatible with the Lithionics recommended charge profile. So I've gone through a couple of different iterations already, actually, on this project. Pleasureway, as I mentioned before, doesn't give you any information on the wiring of the system. So I've basically traced wires and done some experimentation to determine how best to wire this into the Ascent power system. I've got a number of videos. I'm going to pick up on probably my final iteration of exactly how I chose to install it. So I'm going to cut to that video now, and hopefully this will be good information for anybody who chooses to upgrade their charging system. Okay, so this is the setup so far. Here's the DC-DC charger that's, I've got it bolted to the wall with some space behind it for air. 6-gauge wire going to two 60 amp fuses, which is what Victron recommends. Also, that's the rating for this wire. That's following around behind the sofa, and I've got it coming, I've kind of tied it in with the other cables that are here. I just zip tied it to keep it neat. Then we come up here into the bus bars. So negative bus bar, this is there's actually no bus bar, I'm going to add one, but the ground's just attached to the shunt that's here for the onboard current meter, and then this is the positive bus bar, and then I added this short bus bar here. So the way the system is currently wired, there are these two cables that are labeled 150 amp charger that were connected to these 2 points originally. So I took them off of here and put them onto this bus bar right here. And these 250 amp charge cables originate under the driver's seat. One of them comes from the solenoid that Pleasureway installs. The second one is connected to the relay that's part of the Mercedes-Benz auxiliary battery circuit. So both of these are keyed off of when the ignition is on. So one just engages the Mercedes-Benz relay, the other engages the Pleasureway solenoid. And originally they were just tied together, so I did the same thing here. And then this cable here goes to the input of the DC-DC converter. So when the solenoid and the relay engage, you get power here, and that powers the DC-DC charger. The output of the DC-DC charger I've then just kind of wired back up onto the positive bus bar. So at some point I need to change this fuse from 150 amps to probably 60 amps to make it compatible, but I've got the breaker at the DC-DC charger, so I think that's fine. So that's the wiring that's up to here. So the other issue is that these two, or the issue that I'm dealing with right now, there are some issues with running it this way. Runs fine most of the time. When it revs up, this voltage right here tends to drop, and I think it's because of the solenoid. So my next step here is to isolate this and only use the Mercedes-Benz relay output and not use the solenoid, and do a test there. These are both 2-gauge wire, which is rated 150 amps at 25 feet. So we're going to be drawing about 30 amps with the single controller, and when I add a second controller, it'll be 60 amps, so well within half the rating of the wiring. So in order to do that, these two lines actually go through this charge line disconnect switch. So I'm going to need to take this off and then separate the two wires and just use one of the wires here, and I'm going to run a test in that way. So while we're in this area, this charge line disconnect does two things. It disconnects the alternator charge lines coming in, also disconnects the solar. So what I did was I cut the solar wire that's going into the input of this switch, and I wired it now directly to this positive bus bar. So all this is doing now is just the alternator charge disconnect. The solar doesn't need a fuse. It's got its own separate fuse, and that's how you can identify it. There's also this, Pleasureway put a little tag here saying solar panels, or solar charger, I think it is. Yeah, but it's a 30 amp blade fuse. So what I'm gonna do when I get all this together, I'm gonna replace this with a regular disconnect and add a disconnect for the solar as well. Keep them separate in the system. So okay, so I'm gonna take this apart, isolate the wires, just put the relay on here, and we'll run another test. Okay, so I removed the charge line disconnect switch. In case anybody's wondering, this is just a single pole switch that has basically two terminals. This is, I just disconnected the two lines that come from the under the driver's seat from the solenoid and the Mercedes-Benz aux relay. They were just tied together here. I have no idea why, since it's 150 amp max off the alternator, why they would bother to put two wires off the output, and that these two wires here were connected into this positive bus bar on these two separate lines, and this is just shorted together here. So they were shorted together in a switch and shorted together on a short jumper cable to the bus bar here. So right now what I have is I've separated the solenoid and the relay here. So I'm basically going to just take and wire the relay up to this bus bar and connect it into the DC-DC charger. So there's only a single line coming in. That should be effectively direct from the battery, which is what you want. So you'll get the relay will close and power up the DC-DC charger, which is good. So when the car is off, you're not draining the battery with the DC-DC charger, and you'll just get the relay, which has no resistance in it, going direct to the DC-DC charger. So we shouldn't have the voltage drop. My theory is that the solenoid has a resistance to it, and when it was connected to the DC-DC charger, there's a resistor effectively to ground, so that cut the voltage down. So that's so I'm going to wire this up, relay to this junction box, or this this bus bar, and then we'll give it a test. Okay, so I've got this now where these are the two input 2-gauge wires coming from under the driver's seat that were going into the cutoff switch So I've separated them, and I've determined which one is the Mercedes-Benz relay and which one is the Pleasureway solenoid. So I've just taped up the solenoid for now, so it's not going to touch anything. What I want to do, just as a quick test, I wanted to just connect the relay output to the input of the DCDC charger, which is right here. And I used a 1/4 inch short two-pole bus bar, just because Pleasureway used 1/4 inch posts here on their bus bar. So this was a way of just adapting the output of their cutoff switch. They have this little jumper cable that goes 1/4 inch to 3/8 inch. So the lugs that come from the front engine are 3/8 inch. So I just have this bus bar that I have with 3/8 inch lugs. So I took the relay, connected it to one lug, and the other is just that jumper wire that Pleasureway had in from the cutoff switch to their bus bar it's just jumping over to this 1/4 inch. So this is just really adapting the two different lug sizes right now. So I wanted to just do this quickly as a quick test, and it was a very successful test now. So the relay kicks in once the engine is on, and then feeds the voltage direct from the alternator battery to this bus bar that then just goes directly to the over here, and let's get over here, and into the DC-DC converter. So the cutoff switch right now is this relay. So if I ever wanted to disconnect the alternator output, I just pop this, and now it's disconnected and this is off. And then I just turn it back on here. So it's fused and it's got a disconnect on the alternator. What I'm going to do now is, just to finish it up, I'm going to take this wire that I created, this six gauge wire to 1/4 inch lug. I've got a 3/8 inch lug for this, so I'm going to just cut that off, put a new lug on here, and just wire this directly to here and eliminate this jumper cable just to clean it up. What I'm going to do is, you'll see in future videos, is all of this space up here. All it is are two bus bars, a positive and negative bus bar. So I'm gonna, my plan is effectively to remove this battery box to gain this space and put the lithium battery right here. And then I'm just gonna put two bus bars up against the back of there, and then I gain basically all of this storage space. So for now, I'm gonna change the lug, clean up the wiring for the short term, take it for a drive test. Okay, so I've just finished cleaning up the wiring. So I took the input to the DC-DC converter, I cut off the 1/4 inch lug, put in the 3/8 inch lug, so it goes directly on this new bus bar. And that is bused together with the relay output of the Mercedes-Benz aux relay under the driver's seat. I just took the Pleasureway solenoid for now and just taped it up. I'll probably tie it, put another bus bar here. One of these lugs here, just kind of tie it so it's not floating around, or I might tape it to something, I don't know. Anyway, the main bus bar here has this plastic cover on it to protect it so nothing else shorted out. The output of the DC-DC converter I've just got running to the bus bar, positive bus bar here that Pleasureway put in. So this 1/4 inch lug to 6 gauge wire. So then I just clean these up coming back, and notice the wires come in under here, and I kept extra wire here, and I made like a little service loop for both the input and output in case I need to pull more slack when I'm rewiring the main wiring. I highly recommend this to anyone. These go into two 60 amp breakers and then tied to the DC-DC converter. So I just ran a test, ran down the battery a bit, and it worked great. Kept it at a constant 14.1 volt input from the alternator, which is what I'd expect. Before that was, with the solenoid in there, that was varying quite a bit. which really shouldn't have happened. And I'm just guessing that, yeah, it's not like a relay, it's a resistive load, so it was cutting down the impact of the voltage. So this is the little cover that Pleasureway includes, so I'll protect that up. So I'm going to call that done for now. Again, once I get everything together, test the battery out, then I'm probably going to replace this battery box and just take 2 bus bars and mount it on the wall to give me more space back. Okay, this is a wrap-up of the charge circuits. So everything the DC-DC charge controller right here is installed. I decided not to upgrade the Progressive Dynamics charger for 2 reasons. The cabling that they're using is 8 gauge. 8 gauge will run 80 amps, but only for about 7 feet. And when I had this out, I was tracing the 12 volt lead, and it looks to go into a loom that goes into the passenger driver's side ottoman. I don't know how long that run is going there and back. I couldn't find it in this. It's not in the bus bar. It goes down into the spider controls area underneath the driver's side ottoman. So I didn't want to risk it. I didn't want to overload that wire with 80 amps. 8 gauge will run 45 amps for 15 feet easily. So that's fine. But running 80 amps would be a risk. The other reason is that I intend to replace the inverter, the 2,000 watt inverter under the passenger side ottoman, with a new 2,000 watt inverter from Xantrex that includes a 100 amp charger that's lithium compatible. So once that's in place, then I'm going to remove this altogether, and the charge current will come from these two wires that are coming from the inverter. So I won't have to worry about the 8 gauge wire at all coming from the AC charger. I've got 4-aught wire here carrying 100 amps, and that'll charge my dual lithionics system much faster than the 80 amp anyway. Well, faster anyway. So the other thing to note is this 4-aught cable. This is something that one of the good things that Pleasureway did was, you can see back here, this is labeled as a 250 amp inverter. So this wire is actually sized for a 3,000 watt inverter, which is really significant, because I intend to use to run the air conditioner off the Lithionics batteries, and that instantaneous charge is going to potentially pop up above 2,000 watts. So that's it's just good to know that the wire is sized to handle that kind of load. Next step is I'm going to be putting the Lithionics battery right here as a first step until I get until I remove this battery box. And then the way that's going to work is, this is my box. I took a page out of Humble Road's book, and this is just a lightweight version of the Lithionics battery. So it's going to fit in there just like that. And I'm going to build a bracket that'll brace it to the sofa leg, so it doesn't move around. I don't think so. It's 80 pounds. It's not going to go anywhere. The other thing I'm going to do is install a battery disconnect switch right here. So this is so we need to be able to handle 250 amps from here. Basically, I'm going to connect it through the switch to this bus bar right here. So that's a very short run. So I only need 1-aught cable for that. So I'm going to run a 1-aught cable from here through the disconnect switch and over to this positive bus bar. And then the negative, I'm going to come off of this. This isn't really a bus bar. Well, it is kind of a short bus bar with just 2 lugs. I'm going to hook the negative of the battery here so that it picks up this shunt for the system. So that'll be next video. The battery is in. I just now need to do some carpentry work and remove these batteries, and then we'll have the Lithionics in place. All right, well, thanks for watching, and stay tuned next time when we'll tackle the battery install.